Hello, Jeremy here from 3D Infotech with another quick tip for you. In this video, I will be discussing probe compensation. Probing devices like probing arms and laser trackers, they only know the center of your probe tip, not where the probe contacts the part. So we need to teach PolyWorks how to offset the point for the size of your probe. This is called probe compensation. And PolyWorks offers two methods for probe compensation. If you're not sure which method your device defaults to, you can navigate to your options. And if you're in 2023 or older, you can navigate to Tools, Options. If you're in PolyWorks 2024 or newer, that will be in File, Options. Within your Options window, you'll navigate to Probing Device and click on Compensation Method. And for my probing device, my default method is compensation point, but I could specify probe orientation if desired. I will show you both methods, but let me start with compensation point. Now, let me demonstrate how to do compensation point on this plane. And let me give you an example of a good compensation and a bad compensation. Let me demonstrate. First, here's the good one. 1, 2, 3, 4, confirm. Now, here's the bad example. And I'll try to probe the same points. 1, 2, 3, 4, confirm. Did you spot the difference? If you missed it, no worries, I'll explain it in a little bit. But let's look at the results. Notice, for my good plane, the measure plane is on my part. And that's expected. But let me show you the bad example. And notice how the resulting plane is floating away from my CAD. Let's explore why. When using compensation point, users can probe a plane as normal. After probing a feature, what's really important is the location of the probe when confirming the plane. Typically, you lift away from the plane and press the confirm button. If you lift into the plane, the points will be offset incorrectly, often adding additional thickness to your plane. This same phenomenon can also be applied to hole features like circles and cylinders. Let me demonstrate. Once again, I'll start with the good example. 1, 2, 3, 4. Confirm. And let me demonstrate with the bad example. 1, 2, 3, 4. Confirm. Did you spot the difference? If not, I'll explain in a little bit. But let's look at the results. And you'll notice that the good circle is within tolerance of my diameter, but my bad circle looks like it's off by the diameter of my probe tip. Let's investigate why. Users can probe a hole as normal. Once finished, the location of the probe is still important when compensating. Typically for a hole, users would just move the probe towards the center of the hole and press confirm. Moving the probe outside of the hole while confirming may result with a smaller diameter. So once again, PolyWorks offers two methods for probe compensation, and this was the compensation point method. Let me go back to my options and switch to probe orientation. And once again, I'll demonstrate a good and a bad example. Let me start with a good example. 1, 2, 3, 4. Confirm. Now, let me demonstrate the bad example. 1, 2, 3, 4. Confirm. Did you notice a difference? If not, I'll explain later. But once again, notice that my good plane is on my CAD, while my bad plane is floating away from the CAD. Let's investigate this. When using probe orientation, your very first point is important, and we typically recommend your probe orientation to be within 45 degrees from the surface normal. Your measurement may become problematic when your first point is tangent to that surface. This same phenomenon could also apply to the hole features like these circles. Let me go ahead and probe them. And once again, I'll start off with a good example. 1, 2, 3, 4. Confirm. And now, let me do the bad example. 1, 2, 3, 4. Confirm. Notice the difference? Well, once again, you'll see that the results are just like what we saw before. My bad example is off by roughly the diameter of the probe tip. Let's explore why. Again, probe orientation relies heavily on your very first point, and it must be oriented towards the wall. All subsequent points can be oriented to the wall as well. What's dangerous is if you probe that very first point tangent to the wall. And this tangency brings ambiguity whether you're probing an internal or external feature. So there you have it. This is probe compensation, and then once again, there's two methods. There's the probe orientation method, which relies heavily on the first point, and then there's the compensation point method, which relies heavily on the last point. Understanding these differences will help you get reliable measurements. Thank you for watching.